Okay. Hello everyone. I'm Professor Pankaj Biswas. I am live now for the course of welding application technology. If you have any queries, you can ask me questions. Yeah, it is live. The live session is already started. If you have any queries, you can ask me questions. Tanuja Kumari, live session is already started. If you have any queries, you can ask me questions.
Sir, may I ask?
Yeah, tell
Like,
right.
yeah, uh, uh, how should I determine the required voltage and current setting for welding? Specifically, I'm asking for MIG and TIG.
Okay, how? You tell again. Why?
How do I determine the
Uh,
required voltage and its respective current setting?
very
So,
good
especially
questions.
for TIG and MIG welding. And if you
Very
can
good
also
question.
include FCAW, then it's better.
Okay, fine. I'll tell you. Right.
Thank
Actually, there are some power source. Generally, power source characteristics. I think this you have already in this course. Actually, that types of physics of welding and what you can say this fundamental of welding is a little bit not available. So for that, I had already a course you can see that is called Fundamental of Welding Science and Technology. So in this course, I discuss in details whatever the question you ask, na. In details, I have discussed in that course. What I'm telling, understand? So you are asking how to determine welding current and welding voltage. Now you see, generally for a particular types of welding process, the welding power source characteristics, you can say, you can categorize into two different categories that I am just showing you. Then it will be more clear to you. Just I am showing here. I am showing 1 minute. You see, generally the power source characteristics we can categorize into two different categories. Generally, for two different categories, we use these things. One is called CC power source characteristics, another one is called CV. CC means constant current power source characteristic, and CV means constant voltage power source characteristic. So what happens? What we used to do in constant current power source characteristics, the generally the vertical axis represent the voltage and corresponding horizontal axis represent the current. Similarly, for constant voltage power source characteristics, also vertical axis is always V and horizontal axis is current. So if you draw the characteristic curve for constant characteristic curves is generally look like this, which is also sometimes called drooping characteristics. This is very well known to you. This is generally used for, you can say, this types constant current characteristics power source is generally used for manual arc welding process. Why it is used for manual arc welding process, I will discuss in details. And this constant voltage power source characteristics, which is look like this, it's also sometimes called flat characteristics, flat types of power source characteristic. What I'm telling, understand? So constant current power source characteristics and arc characteristics generally, once you draw this arc characteristic curves in a voltage current plot, you will observe that the arc characteristic curves is look like this. What I am telling you, for a particular arc length, you will get a voltage than this in voltage current characteristics. If you draw for a arc like here I am showing, then it will be more clear to you. Actually, for that lot of information is required to know. Then also I am trying to giving you some fundamental things. Then it will be able to understand how to determine the voltage and current for a particular types of welding operation. Now you see, generally these voltage current characteristic curves is look like this, which I have drawn. This is generally called arc characteristic curve. Generally this power source, this is called power source characteristic curve, and this is called welding arc characteristic curves. These two curves, wherever it's intersecting, this is called working point. This is called, you can say, working point. This is called working.
What you were showing is not coming on screen, sir.
Okay, I have to share. I am just showing it. Yeah. Now it will come by.
Okay.
1 minute. Thank you. I am showing, then it will come. Yes, it will come now. Thank you actually for your these things. This is a very interesting question, but what happens for that, you need lot of information, frankly speaking. But what happens, I'll try to make you understand as easy as possible. Now it will it is shown. So you see, this is constant current characteristic curve, and this is called constant voltage power source characteristic. Now is it visible, right? It will come. It will take some time. Now you see,
it's visible now.
So this is called power source characteristic curve, and this is called generally this one is called arc characteristic curve. So this is arc characteristic curve. So this arc characteristic curve and power source characteristic curve, wherever these two curves crossing together, this point is called working point. What I am telling you, this point is called working point. What does it mean? Working point means this is the operating point. That means for a particular arc length, if you know the arc length, and if you know the characteristic curve of this power source, so corresponding to this arc length, you will get a voltage. This is called welding voltage. This is called welding voltage. So corresponding to this welding voltage, you will get a, you can say, corresponding to this welding voltage, you will get a current. This is called welding current, IW, you can say. Now you see, this end point of these things is called short circuit current, and this is vertical. This maximum voltage is called open circuit voltage, VO. You know these things very well, because if you know the welding basics, I think these things is very well known to you. Now for a particular types of arc length, you can say you will get a particular types of voltage. So that voltage, corresponding to that voltage, you will get a current which is generally intersecting this characteristic power source characteristic curve. Then only corresponding to whatever the current you will get, that is generally called welding current. Now these things you can calculate in other way also. Like what happens? So this constant current power source characteristic generally used for manual welding purpose, you can say, and this is called constant voltage power source characteristic. It is generally used for, you can say, this is generally used for automatic types of welding process. Where it is used, I am just showing. It is generally used for automatic types of welding process. So like TIG welding can be automatic or semi-automatic. What I am telling, understand? But TIG welding generally, it can be what is called TIG welding. Generally, it's operated manually. Now, what is called a manual welding process, that also you should know. And what is called the automatic or semi-automatic welding process, that also you should know. Generally, in a welding process, you need to control two things, you can say. Two things in the sense, one is called electrode, or you can say filler wire movement. Another one is called welding speed. What I am telling, understand? Like you see, let us consider for a MIG welding process. For a MIG welding process, you know, there we use a nozzle. So inside this nozzle, through this nozzle, generally gas as well as consumable electrode is coming out for MIG welding process. MIG welding is a, what types of welding process? MIG welding is a, what it's called? You are asking this thing, this is not in this course. What I'm telling you, so this is called generally contact tube. This is called contact tube. So from here, generally you can say this consumable electrode is continuously fed by wire feeding mechanism. So you see, so this wire feeding generally, if it is automatically done, and there is a welding speed, there is a welding speed is also required to do the welding operation for a particular length. Their welding speed is also required. Now, if both wire feeding as well as welding speed is automatically controlled, then that is called automatic welding process. Now, if any one of these, either let's welding speed is controlled manually and wire feeding is done automatically, this is called semi-automatic. Now, if both consumable electrode as well as welding speed is controlled manually, that is called fully manual welding process. What I am telling, understand? This you should keep it in mind. Now, in case of MIG welding process, generally here we preferably we generally use what types of power source characteristic? Constant voltage types of characteristic. And here we used a very interesting characteristic, constant voltage characteristic have a very interesting types of characteristic is there, that is called self-regulation of arc characteristics is there. Self-regulation of arc characteristics are there. What does it mean? Self-regulation of arc characteristics means generally here the arc length try to remain constant throughout the entire welding process. So if suddenly there is a change of this, that means arc length is occur. If generally depending upon arc length, you can say the voltage is dependent. What I am telling, and depending upon the arc length, the voltage is dependent. So B is a function of, you can say B is directly proportional to arc length. So if arc length increase or decrease, then voltage also increase or decrease. So if there is a marginal voltage change, then in case of flat characteristics, you can observe that in case of flat characteristics, there is a, for a marginal or a small amount of voltage change, there is a huge change of current is there, more change of current is there. So that's why what happens, if there is a fluctuation of this electrode is there, then what happens, there will be either lowering the melting or increasing the melting by increasing the current or by increasing the current more, you can say. For a small amount of voltage sense, more amount of current is changing here. So for that reason, generally what happens, this here generally there is a very interesting characteristic for flat types of power source characteristic is that is called self-regulation of arc. That means here always the arc length try to remain constant. What I am telling, understand? That means this arc length, whatever the arc length here you are getting, this arc length, this generally try to remain constant. Why? Because if there will be marginal fluctuation, then that marginal fluctuation automatically either increase the current drastically or decrease the current drastically. Then what happens? Your arc length regain to its original length. What I am telling, understand? That's why this constant voltage power source characteristics is used for automatic types of welding process. Now you got the idea what is automatic welding. Automatic welding means if welding speed as well as filler wire speed, you can say, if both the thing is controlled automatically, then that is called automatic welding process. What is manual welding process? Manual welding process means if this welding speed as well as filler wire, both the things is controlled manually, then that is generally called manual welding process. That is generally, you can say, one of the example is this thing is SMAW, that is called shielded manual or shielded metal arc welding, or sometimes it is called shielded manual metal arc welding process. What I am telling, understand? Here generally you see, or you can say this is also called stick welding process. So in this welding process, you can see that both filler wire continuously feed as well as your welding speed also done manually. Similarly, in TIG welding also, you can say sometimes we use the filler wire with the help of left hand, as well as there is a torch which is non-consumable electrode. That torch also move by right hand. What I am telling you, so both the things we also use manually. That's why wherever there is a manual types of welding process, there is a general chance of fluctuation more, you can say. So wherever there is a chance of fluctuation more, then what happens, for more the more change of fluctuation means more change of arc length will be there. So more change of arc length means more change of voltage will be there. So in case of constant voltage arc characteristic, you can observe that if there is a voltage change, the current change also, if there is a current change also is there, but that current change is not that much of high like constant voltage characteristics you can see. So that's why here generally for a fluctuation, generally current is not increase or decrease drastically. So here generally for manual welding purpose, if you use this, generally throughout the entire process, your weld deposition will be remain constant, you can say. Though there will be some fluctuation of hand or shaking of hand, then what happens, vibration, if there is any vibration of your fan is there, that vibration does not create mass problem in the weld bit deposition. Due to this less variation of current and voltage, you can say. But in case of this constant voltage power source characteristic, that things is there. Now I have already told you that for a particular arc length, there is a particular voltage is there. Corresponding to that voltage, whatever the means crossing point, you can say, corresponding to that voltage, whatever the crossing point you will get in this arc or power source characteristic, corresponding to that thing, whatever the current you will get, that current is called welding current. This way generally from chart itself you can get the idea for a particular welding current, what should be the welding voltage. Apart from these things, you can play the things by using some other technique, by some analytical method also. Like I am just telling, let us consider for a particular welding operation, you know the power. Let us consider power is equal to P. Okay. So let us consider you have asked that your power is, welding power is 5 kilowatt. Now, if you show 5 kilowatt, we know power is equal to efficiency into voltage into current. Correct? Let us consider this efficiency is something. Okay. So you can say power is, let us consider here I am considering 100% efficiency. So you can say power is equal to voltage into current. Now, here you can play your game. You can see, you can refer, like for a particular types of thickness of plate, let you have given that your power requirement is 5 kilowatt. So 5 kilowatt you can get by different way. Like if you consider 20 volt as a current voltage, then what should be the current value? To get 500 generally, then current value will be 250 ampere. What I am telling, understand? This way you can also calculate what I am telling. And now if your voltage is 25 volt, what I am telling, understand? Then your current will be how much? 20 ampere. Like this way also you can calculate. So depending upon your requirement, you can do it in different way. What I am telling, understand? But beforehand you should have some input in your hand. That means for a particular welding operation, for a particular thickness of plate, what is the power requirement or what is the voltage requirement, or this any one of these things if you know, then other parameter you can decide automatically. This is generally some statistics also. So you will find that, okay, once you will purchase a welding machine, there will be a, you can say, there will be a manual, welding manual, you can say a handbook will be provided, that welding company who generally will supply the welding machine. In that welding manual, you will find different types of means different types of information related to power requirement, current requirement, voltage requirement, what I am telling, understand? So these types of things generally you can easily find out. Now you see, for these two steps I have told you, by these two steps you can generally find out your current and voltage very easy way. But what happens, some other advanced techniques also are there. So I will suggest you can go through my previous course where I discuss in details about physics of welding. So there generally you will find the basic fundamentals of all this concept very clear way. What I'm telling, understand? Because for understanding this concept, it will require around 2-3 lectures. What I'm telling, understand? So whatever that things I am trying to show you within 10 minutes, you can see. So it is better to, if you want more knowledge in this, you can go to what it's called, you can go to my previous course that is called Fundamental of Welding Science and Technology. There you will get all the information, whatever you want. What I'm telling, understand? So this power voltage into current, its unit is generally what? That you know. Okay, you got my point, bhai?
Yes, sir. Yes, sir. Thank you, sir.
Thank you. Thank you. This is very simple things actually. I make you understand. Okay. Okay. Some others also ask some question. Yeah. 1 minute. Yes. So निशा भारती 25 को एग्जाम ही पास कैसे किया जाए? Okay, actually Nisha, this exam will be very you can say fundamental types of question will come, very fundamental types of question, in the sense generally in this course whatever the things I taught, you can see what the lectures I have provided in this course. If you just go through this lecture thoroughly, you will get every information from there. What I'm telling, understand? And I have, if you want some more knowledge, I have provided some reference books also. You can go through that reference book also. But what happens, whatever the fundamental basics, everything I provided in this course, you go through my lecture thoroughly, you will get every information. And this exam will be generally MCQ types of exam. Just simply you have to, if you know the things, there will be a tick. That's MCQ means one question, 4 option will be there. Out of 4, 1 can be correct, 2 can be correct, or 4 can be correct. What I'm telling, understand? So you have to just tick the things. So it will be, I think, 2-hour exam. Around 50 to 100 question will be there. You have to tick. That's all. Okay, Nisha. And Mintu Kumar, which types of question will come in exam? Mintu, I have already told you the question will be very basic, very simple question. If you know if you follow my lecture note thoroughly, you will get every information. Okay, you will get everything. That I can say. Yes, some others. Yeah. Very simple question, very fundamental, simple question. Just I am telling you, you just go through my lecture note thoroughly. Whatever the lectures I provided, you go through this thing thoroughly. This will be required not only for this exam. I am telling you, this course will be highly informative types of course, you can say, related to welding, because these types of course or these types of fundamental things, I think very rarely available in NPTEL, I have seen. That's why I'm just telling you, you go through these things very thoroughly, very fundamental things I used to teach and I taught in this course also. So whatever the things I taught, go through this lecture thoroughly. Everything will come from these lectures only. What I am telling, understand? Kundan theory was okay. Then, sir, we can pass our final exam by studying the assignment. Not only assignment, the question will be more or less similar to this assignment types of question. Samad. That's why what happened, this MCQ types of question only. So I am telling you, go through my lectures note thoroughly, because this lecture note not only will be help now, this will be help if you want to in higher study. That times also these types of information, whatever the course course material I provided in this course, that will be very much helpful once you will be interested to do research in welding related field. What I am telling, understand? Because I have already told you, welding is such a course where you will find all the flavor of all science, you can say, the flavor of all science subject. Okay. So that's why I am just telling you, you go through this lecture thoroughly. Whatever the information or lectures materials I provided you, if you go through this, every question will come from that only. Okay.
Thought area पूछ ले.
Shamad. Yeah, tell, why? You are not audible clearly. Hello?
Yes, sir.
Yes.
Thought area. Tell me about something thought area.
Throat area.
So
Okay.
About
yeah,
that,
I am telling. Very good. You see, so it will be better. I'll draw the things and I'll explain these things clearly. Then it will be very clear to you. Yes. So especially for plate welding, I am sharing my screen. After that, I will explain. You see, generally in case of plate welded joint, you can observe that plate, what is called a plate welded joint, generally the plate welded joint, you can see it's generally triangular in nature. Plate welding generally we used to do, this is on horizontal plate, over this there is a vertical plate, this we want to insert. So this, but here I am little bit bigger way, generally I am drawing these things. So once you do the welding, this welding generally looks like, its cross section looks like triangular in nature. You can see this cross section is look like triangular in nature. 1 minute, it will be better to. This is triangular. So this triangular shape types of welded joint generally is called fillet welded joint, that you can say. Now in this fillet welded joint, some important point you should know. This corner point generally called toe of the weld, and this is generally called leg length. This is generally called leg length L. Let us consider I am representing leg length L. This is on leg length. This is another leg length. You can see. This is called leg length. Now you see the throat area means the throat thickness is the thickness, you can say distance from this corner of this, you can say corner of this joint to the perpendicular. That means you can say perpendicular distance of this face surface. This is called face of the weld. What it's called? This is called face of the weld. Now you see this face means this hypotenuse of this triangle is called face. Correct? Now, so here this is called throat thickness. This is called throat thickness. You can see in this welded joint, you can see that this is the, you can say that critical zone, you can say, because here generally this is the minimum distance of this from this corner point to this face This is the minimum distance you can say. So this is generally perpendicular distance, that this is the perpendicular with this face. Face, you see, this is called FSCE. This is called face. This you should keep it in mind. Now you see, so in this throat, so if you just extend this weld, that means this welding is done like this. So you see this weld, if you do it for a particular distance, then you see this throat cross section you will get, it will be like this. It will be like this. It will be actually what? It will be a cross sectional area. It will be a cross sectional area. It will be a cross sectional. So you can see here, this is a parallelogram types of shape you can see. So you see, so this, or you can say this is a rectangular types of area you can see. So this rectangular area, it has a area actually. This area is called, you can see the throat thickness into weld length. Let us consider this weld length is this mass. This weld length is this mass. Let us consider. So the throat area will be how much? Throat area will be just equal to, you can say, throat thickness T, that means width into length. Length into width is called area of a rectangle, correct? So T into length of the weld. What I am telling, understand? So throat area means throat thickness into length of the weld. That is the throat area. Is it clear? Why?
Yes, is it clear,
very
sir?
simple. So this is very simple. Okay. Okay. Because here generally this area generally we consider to find out, you can say, to find out the shear stress. This area, then whatever the different stress related for designing a welded joint, whatever the generally stress, welding stress and other things we consider, there generally we take into account this throat as a critical zone, correct? So every area, whichever area we consider in a welded joint to calculate this stress value, there generally we consider this throat area. So throat area equal to your throat thickness into length of the weld. That's all. Okay. This is very simple. Is there any questions? Kundan?
Yes, sir.
Do you have any question, why?
Not for now, sir. There are a couple of things that I'm thinking. But,
Yeah, tell me.
Sir, like if someone want to make like good career in welding, what kind, like may you please like suggest some kind of courses or some kind of sector where we should try to find job to have better future, because generally as welding is a very conventional kind of field, not as IT, so the pay scale are not that high, like in general I'm saying, not counting those people sitting on the top in some corporate or something. So if you are having a big aspiration,
very good, Kundan. This is a very good question. You can't imagine actually, once you'll be a welding expert, because once you'll be in a manufacturing industry, you will find what is the value of a good welding expert. Because in a welding industry, in any manufacturing industry, whenever you will go, there the main things is called the quality control department, you can say. This quality control department, they inspect the quality of product. For a manufacturing industry related thing I am telling, like shipbuilding, then what it's called railway industry, aerospace industry, so yeah, any types of engine industry, car making industry, whatever you want actually want to know. So everywhere you will go, you will get that there the main joining techniques is welding techniques, and the quality inspection or quality control department, they generally check the quality of weld joint on. So whoever they are in a weld means quality control department is valuable person than others, not like that. In quality control department also you will find there are general manager, so many high posts are there. So they generally used to gain that things with the help of their knowledge, you can say. So just for welding, you can imagine, yeah, there are different types of other certified courses are also there. Like American Welding Society, they used to provide different certification of course, mean different certified course for the, like for underwater welding, one types of certification, for for different types of welding technique, different types of group of welding technique. They generally make a set of different certificates. So what you can imagine, for a particular certified course, you can imagine you can earn more than like any things you can't imagine actually. What is the value of a that I don't want to say in this open forum, but if you want to know about more about this welding future, then I can tell you in telephonic way also what I am telling. Understand? So anytimes you can call me, bhai. This is not. Don't think that okay. What I am telling, Kundan. Don't think this welding is like whatever the roadside, whatever the things you used to see at night time. Generally, very simple levers they are doing. Generally, stick welding and other things, and that's all welding. No, not like that. You can't imagine what is the value of a welding expert. You see, we are also welding expert. You see, but you can't imagine actually what are the different types of problem or consultancy project we used to handle. You can't imagine what are the means because lot of information, lot of very tough problem which generally used to come to us to solve that things with the help of our consultancy types of service, you can say. You can imagine what types of problem generally, not only this problem is facing in roadside, so big R&D section, so big company, what I'm telling, understand, they used to come to us to discuss how to solve this thing, how to do this thing, how to do their things. We generally like do whatever the knowledge we gain, whatever the things actually, as we are in this field, we are generally very frequent to means know what are the different things available in these things. That's why what happens, you can say, as we are in task of these types of course, that's why we know little bit modern thing as well as very old things also of this welding process. So we generally used to give the solution of different problem which is arised in industry. So that's why if you'll gain knowledge in this field, I am sure what will be your future you can't imagine. Okay, but you should be fundamentally very strong. Okay, that I can say, Kundan. So later on also you can talk with me. I will send you my contact number. Okay, or you can directly mail me in my official mail ID. Right? Anytime you are always welcome. Okay, you just give your 100% effort. I can say you will be in a very big position.
Thank you, sir. Thank you so much.
Okay, bye. Okay. Yes. Any other questions? One minute.
Hello, sir.
Yes. Tell, bhai.
Hello, sir.
Yeah.
Hello.
Yes. Am I audible,
Sir,
bhai?
it is possible to. Yes, sir. Yes, sir.
Yeah, bhai.
Sir, it is possible to go for practical knowledge to IIT Guwahati.
Definitely. Actually, you see, actually that types of option is also there, right? You see, like generally in this course, whoever will perform well, there is a chance to do. You can say that information you got already. So yeah, so you can do intern with me at IIT Guwahati, where you will get all the techniques whichever I taught in this course, every techniques related thing, and that every welding machine also is available in IIT Guwahati. So you are always welcome, bhai. If you want to do some practical in IIT Guwahati, you contact with me. I definitely will help you in my level best. What I am telling, understand? I am always with you people because
Yes,
you took my course. now you become my disciple, you can say. What I'm telling, understand? You are my shishya now. What I'm telling, understand? So any times you just contact with me. I am always with you people. Whatever the help is required, if it is within my limit, I will definitely help you. Okay, you are always welcome.
Okay. Thank you, sir.
How to attempt numerical question? Mintu Kumar. Which types of question? Oh, so Mintu, actually, you see, whatever the things I told in numerical problem also, whatever the things I taught, so the question will be based on that only. So like you see, there are in this course, whatever the topics in welding design related things I taught, here generally I taught related to welded joint design based on static loading cases. So for that, I have solved different types of problem, different types of fundamental derivation I made. You go through all these things, you will get everything will be fundamental question. You go through all these things, you will get everything and you will be able to solve everything very clearly. I'm just telling you. Okay, Mintu, you need not to worry about. So you go through my derivation, you go through my lecture thoroughly, everything will come from there only. I am just telling. Once your fundamental will be clear, everything you will get. Piyush, sir, what will be the question paper pattern? MCQ, Piyush. Question pattern will be MCQ. Yes. Tell, why?
Sir, please tell me that how to find previous year question, which is that's already exam. Because
yeah,
I'm
very
searching
good.
too many times on social media.
But
I'm
okay,
not.
previous year question, I think that NPTEL team will provide that things. Okay, what I'm telling, understand, why? Like, because I think we don't have authority to give it to you. Okay. What I'm telling, understand, why? Because this is a open forum, open types of question, they can provide you. I think it is already available in this site, or you can talk with them. That will be better. They will definitely help you, because I used to provide all the question paper, all the things every year. Okay, they definitely will help you, right? But question paper pattern will be similar to whatever the assignment we used to provide. This you should keep it in mind. So
Sir,
once you'll go through my yeah.
Sir, I thought after learning, after watching your videos, and I thought I'm cross-check my knowledge on your previous questions, so that I'm asking to you. But I'm
Yes.
nothing find on site Google also.
Okay, you did not find anything. Okay, then yeah, you want like I am just giving example. I am just giving example. Like you see, one problem I am asking. What is the full form of PAW? Like this is a very simple. PAW full form is plasma arc welding. What I am telling, understand? So let's see.
Plasma arc welding.
Yes, very good. That's what I am telling actually. So generally question will be like that. You should know the very simple thing. So I will give you 4 different option for this full form of what is the full form of this, or then you have to find out this thing. I have given you a numerical problem. So in this numerical problem, I ask what is the shear stress value. So if you know the basic fundamental of these things, and I will give you the solution in this 4 option itself. So in that 4 option, you have to, if you know the correct procedure, then only you will be able to give the correct answer. What I'm telling, understand? Otherwise, you will not be. So you should, the question will be very simple, like whatever the assignment we used to provide, the question pattern will be similar to that. That means in for a particular question, there will be 4 options. That means from that 4 options, generally you can see you have to give one correct answer, or there can be multiple correct answer. What I'm telling you, so that thing generally you have to provide. Okay.
Yes.
Okay, bye.
Yes,
Any other questions?
Thank you so much.
Then also, if you want some more help, you can send me mail. Right? I will definitely help you. Okay. Like Mintu Kumar, he asked, sir, please tell us how many number of numerical question come in exam and how can we solve. Mintu, actually, you see, The numerical question will be, you see, generally there are around 20-hour lecture or 20 different lectures or 22 lectures I think are there. So you can say each and every lecture will carry more or less equal number of questions. So 20 lectures means per lectures will contain 100 questions will be there, I think 100 question. So out of 100 question, 5 question will come from each lecture, you can say. Akash, Sriram, sir, when the transcript of this course is going to be released? Sriram, you asked these things. Transcript I think already is done, and before your exam itself it will be provided, I think. Okay. Tanuja Kumari, sir, question will come in the form of MCQ. MCQ only. Tanuja, question will come in MCQ form only. Pranesh, if we do theory assignment question, can we pass? Actually, you see, only assignment will not pass you. What I am telling, understand? Because you should get minimum some qualifying mark is required. So theory assignment mark is not sufficient for this. If you get all full assignment mark also, then also you will not be able to pass. You have to appear the final exam. Then only you will be able to pass. Okay. I think there are no negative marking and all the things. Just the question will be, you see, this course will help you. I am just telling you, go through this course thoroughly. This course will help you throughout the whole life, you can say. What I am telling, understand? So my another fundamental course is also available, that is called the Fundamental of Welding Science and Technology. So both these two courses of welding will help you a lot. What I feel, because these two courses I try my level best to put all the fundamental knowledge related to welding. So if you know the fundamental things, then rest of the things you can automatically gain. What I'm telling you, I understand. Rest of the things you can develop by your own if you know the basic fundamental things. Tanuja, so question. So Samad, I gone through all video, but for PAL the final the assignment will help us. Yeah, definitely, Samad. The question pattern will be generally similar to this assignment, but it will not be copied from the assignment. This you should keep it in mind. But I'm telling you, some question may come from assignment also, but the question pattern will be same like assignment. Till today, because we had main exam. Pranesh, what you want actually, Pranesh? You just tell me. What you want, you tell me, definitely I will help you. Sushil, do you have any question? Right?
No, sir. Thank you.
Thank you, Sushil. Sushil, you are from?
I'm from Patna, sir.
Okay, very good, right? Good.
May I speak?
Yes, why not? You can speak.
Thank you, sir. When I asked my first question about how shall we find the appropriate welding voltage and its respective current, you told two options. You gave me two options. Once I have to go according to the characteristics graph, that is constant current voltage or constant constant current power source or constant voltage power source. So there is a graph. I have to follow the graph. The other option that you gave me, that I have to follow the power. Power equals to efficiency multiplied
actually
by voltage.
Actually, Kundan, these two options, just I am showing the very simple things. You can't imagine, you can optimize your power also. There are different options are there, like for a optimum arc length, optimum power, for that different procedure is there. So if you want to know, that's why I told you, if I go for telling how to decide the power and voltage, what I'm telling, understand? Then what happens, that means current and voltage. Generally for manual metal arc welding, constant current characteristic power source is used. For automatic types like MIG welding process, generally constant voltage power source characteristics is used. Whereas in TIG welding, generally constant current or drooping characteristic, as it is a manual types of welding process, you can see. Now you see, apart from this thing, there are different types of numerical methods are there. That's why I told you, like you see, there is a method that is called optimum arc length, optimum power. Corresponding to this optimum power, what should be the optimum, what is called, what should be the optimum current, what should be the optimum voltage, that also you can find out, right? What I'm telling, understand? So there is just, these are the very basic things I told you. By this, apart from this thing, there are some lot of other advantageous types of things are there. That things, if I'll go for discussing, it will take lot of time. That's why I told you, Kundan, if you want to know more about these things, you can directly contact with me, right? Okay, Kundan, tell what you were telling.
Yeah, so I was saying, like in the second option, which I found more easy, like I have to follow the required power. So is there a way to finding the required power for a given material? Like if I know the melting point and things,
Definitely, that you can get. Yeah, very good. That you can get. Actually, you see, for a generally, you see this power requirement is depends on type of material, thickness of material. What I'm telling, understand? So generally, in case of welding, this power requirement is not only depends on a particular types of material. It is depends on, for a particular types of material. If your thickness is varying, then power requirement will be changed. What I'm telling, understand? That's why whenever you used to go for establishing the welding current, voltage, welding speed, or any feed rate, whatever you want, that's why generally you need to do some preliminary study. That is called trial run. What I'm telling, understand? So from that trial run, generally you have to establish your either current parameter, voltage parameters, or other parameters. What I'm telling, understand, Kundan? That's why some preliminary trial experiment is required to do, right? Okay. Generally, what we, so everyone used to do like that way only. So after that, once you get some final input, that input you can make a notebook. From that notebook further, so once you go for doing the experiment, there you can directly use that parameter. Then you need not to do further trial run. What I'm telling, understand? So that way, generally, you can make your data as per your requirement. Okay.
Okay, sir. Okay, so
Because
so I have
welding parameters.
test. It is not like I will get like I will get the output according to the numeric value, that is the melting point and thickness. I cannot derive it directly.
From there also you can get some information. At least you can reduce the number of trial run if you have basic fundamental idea. If you know that that's basic information. What I'm telling, understand? Let us consider who don't have any idea, for getting the final bit shape, he can require 100 numbers of trial run. But as you have fundamental knowledge, so you can get that final shape within 2 trial run itself. What I'm telling, understand, Kundan?
Understand, sir. Understand, sir.
That is the things, right? That's fundamental things is required. Okay.
Yes.
Yeah, because you see, you are now engineer. You gather the basic fundamental things. So you have to apply these things in actual field. Then you will be superior than other normal people, na?
Yes,
What
sir.
I'm telling, understand?
Yes. Thank you, sir.
Okay, thank you, right? I think no other questions are there. So I think hello, 1 minute. Abhishek. Okay, 1 minute. Rekha or Queen, are you there? I think time is up.
Sir, can I ask a last question?
Yes,
Sorry.
definitely. You ask, Kundan. You ask, right?
Yes, thank you, sir. Thank you so much, sir.
Ah.
Sir, in TIG welding, I had gone to a company for a short period, and this was the short time I saw TIG welding. But
Very good.
I observed one thing, that the welder was after every some time he was grinding the tungsten, thoriated tungsten electrode. He was
Very
grinding to
good.
make it sharp. So I thought, I found like he is losing a lot of time doing that. How can one reduce that?
Yes, very good, very good. What again? You repeat your question, by Kundan?
Yeah, sir. So I had gone to a company where I saw the TIG welder who was basically using a thoriated tungsten electrode.
Very
He was
good.
he was sharpening the edge of electrode after every like 10 minutes or so, like quite frequently. So I thought
Okay,
they are
fine.
losing a lot of time in motion. So
Very
how
good.
can one make it more lean, or make it more efficient by reducing this process?
Very good, very good. You see, I think for that, you see, there are different. Frankly speaking, there are different types of TIG welding machines are available. Similarly, TIG welding torch are available. Some torch is air cooled one. Some torch nowadays you can imagine water cooled on torch is also available. So you see, so if your that means electrode will be more heated, what I'm telling, understand, definitely that types of degradation of the electrode will be taken place. That's why frequent that cleaning and other things is required for the welder, what I'm telling, understand. So if you can reduce that types of what is called wear or more heating of this electrode, then you can definitely reduce that things, what I'm telling, understand. Another things I want to tell, why, that's why you see there are different types of what I already told you. There are different types of torch are available. So here one things you should keep it in mind, for non-consumable types of electrode, it is better to use DC, can say En types of polarity. What I'm telling, understand? That is called direct polarity types of things you are required to use. So
You're
you
using
see,
like negative polarity itself.
yes. So now you see this is called reverse DCEN generally straight polarity. So for non-consumable generally, if you use straight polarity, then heat generation will be less. That means it will in electrode. What I'm telling, understand? Like for DCEN polarity, around 30% heat is generated at tungsten electrode, and around 70% heat is generated in what it's called workpiece. So for non-consumable types of electrode, if you generally follow these things, generally or definitely your heating will be less in your that things. This is one way you can reduce the chances of melting or wearing out that material. Apart from these things, you can use some water cooled nozzle. What I'm telling, water cooling nozzle. So where generally your means if you just cool the nozzle with the help of some water cooling system or some other means, what I am telling, understand, that way also you can reduce that things drastically, what I am telling, understand, because generally if you will not follow the well standard one, definitely that types of things will come. Apart from these things, this arc length, maintaining of arc length is also, hello, okay. Okay, time is up. That's why I was calling you. So Kundan, no, I am just telling
Yes, sir.
Kundan.
Yes, sir.
Kundan, okay,
Yes,
Kundan,
sir.
you can.
Yes,
We
sir.
will discuss about these things in details. You just send me a mail. Okay, why? We'll discuss in
Yes, sir.
details
Yes, sir.
about all these things with you. Why? So these are.
Yes. Yes, sir. Yes, sir.
Hello, sir. Hello.